AI is remaking the world faster than the internet ever did. Yet its spark was struck over 2,000 years ago. What if the code humming in our pockets began as gears in a temple? The servers broke. On a rocky island, legend spoke of Talos, a bronze giant who patrolled Crete. Myth, yes, but it framed a question that never died. Could we build a mind that guards, obeys, or rebels? Starts in awe and fear. In Alexandria, Heron built marvels, doors that opened by hidden steam, birds that sang with breath of air. Illusion? Ingenious engineer. Intelligence as mechanism, a performance that felt like will. Centuries later in Baghdad, scholars mapped devices that poured, piped, and played. The Banu Musa wrote of trick fountains and programmed logic routed through water and brass. In Diyarbakir, Ismail al-Jazari drew machines that lifted water and tracked the heavens with layered gears. His elephants and peacocks hid feedback loops, a wisp gods. Across Europe, cathedral clocks paraded wooden saints and roosters at the hour. All was scheduled. Gears obeyed bells. The spectacle planted a cultural seed, that lifelike motion. Then came arithmetic machines. In Paris, a young Blaise Pascal built a box of wheels to appease his tax collector father's burden. One turn made another. Numbers obeyed brass. Abstracted. Leibniz, the stepped reckoner, a calculus of thought. He imagined a universal language of logic. Let us calculate, he said, and a manifesto disguised as machinery. A storm over Lake Geneva, a writer by candlelight. Mary Shelley's creature took shape. She warned that creation without care becomes every breakthrough in artificial minds. In London, Charles Babbage sketched engines of cogs and columns. Ada Lovelace foresaw more than numbers, music, art, symbols, of mind, not just arithmetic. George Boole reimagined logic as algebra, true and false as ones and zeros. A quiet classroom revolution that made reasoning computable. It could enact at light speed. Kurt Gödel proved some truths can't be captured by any system. Completeness is a mirage. The dream of total mechanized new dreams formed. Alan Turing imagined an abstract machine that read and wrote symbols, and with it, the boundaries of computation. He then posed the imitation game. If a machine fools us, war turned theory into urgency. At Bletchley Park, Turing and codebreakers fed logic into whirring bombs, unmasking secrets and bending history. Machines reconfigured machines. After the war, Norbert Wiener coined cybernetics, the science of control and communication in animals and machines. Feedback was the magic word, and steer. Warren McCulloch and Walter Pitts sketched an artificial neuron, simple on its own, powerful in swarms. If brains are networks of thresholds and signals, perhaps think fires. Summer 1956, Dartmouth. John McCarthy assembled bold minds to birth a field and named it artificial intelligence. They dreamed of machines that were wiser with experience. A flurry followed. Newell and Simon's logic theorist proved theorems. The general problem solver tried to mimic human reasoning by searching possibilities. Minds. Languages for thinking machines arrived. At MIT and Stanford, John McCarthy forged Lisp, crisp and recursive, a playground for symbolic reasoners and expert dreams. Learning from examples. Frank Rosenblatt's perceptron read letters from pixels. Newspapers hailed it. The Pentagon funded it. A camera learned. ELIZA. Weizenbaum's program parroted a therapist, reflecting users' words back with uncanny timing. Some believed it understood. The mirror's empty. Shaky the robot rolled through rooms at SRI, mapping, planning, nudging blocks. A machine having goals in a physical space. Humble steps, but the world's goals. Reality pushed back. Minsky and Papert mapped limits of perceptrons. Lighthill criticized grand claims in Britain. Money thinned. A chill crept in. those retreated to warmer rooms. Yet expert systems caught a spark. Dendrol guessed molecular structures. Mycin prescribed antibiotics, if only on paper. Knowledge codified in rules, engineers by the busload. Japan announced the 5th generation, parallel logic machines to leapfrog the West. Money flowed, expectations flew, and brittle rule systems ran horsepower again. Then the floor dropped. Specialized Lisp machines crashed as cheaper workstations undercut them. Funding froze. Another winter arrived. Brutals break when the world intrudes. Backpropagation. Rumelhart, Hinton, and Williams showed multi-layer networks could learn internal features. Stacked functions became gradients as hands. Judea Pearl armed machines with belief. Probabilities flowed through graphs called Bayesian networks. Uncertainty, once an enemy, became a language. From statistics came sharp edges, support vector machines. Vapnik and Cortez sliced data with maximum margins, an elegant geometry of decisions that dominated the late 90s. Reinforcement learning. Rewards and penalties tuned behavior. Watkins Q learning, Sutton and Bardo's foundations. At IBM, TD Gammon learned backgammon by practice, not
In 1997, Deep Blue defeated Garry Kasparov. Brute force search, exquisite heuristics, and silicon speed humbled a world champion. Intelligence at metal walls. Robots met the open road. The DARPA Grand Challenge sent driverless vehicles across the Mojave. The first year, they failed spectacularly. Then they learned. Fei-Fei Li gathered the world's pixels into ImageNet, a cathedral of labeled images. When data swelled, models grew hungry. The tipping point waited. GPUs, built for games, became engines for learning. In 2012, Hinton's team unleashed AlexNet on ImageNet. Errors plunged, the field reeled. Floodgate blowing open. Convolutional nets saw edges, textures, then concepts. Speech recognition tumbled, translation lifted. Hierarchies of features, learned end-to-end, turned micromanagement required. Then Go, the ancient game of intuition. AlphaGo studied millions of positions and taught itself deeper patterns through reinforcement learning. In Seoul, it faced Lee Sedol back. Attention is all you need. Transformers learned sequences by focusing, all at once, on what matters. Context became a canvas. Memory. Pre-training changed the game. BERT absorbed language to fill blanks. GPT predicted the next word, then paragraphs, then essays. Scale acted like gravity. More data and generative models found paint. Diffusion models reversed noise into images. Text to art engines bloomed. DALL-E, Stable Diffusion, Midjourney. A sentence could sound. In labs, AI bent proteins. AlphaFold mapped life's tiny knots from sequence alone, offering blueprints for drugs and enzymes. Intelligence, once a parlor reinforcement learning from human feedback aligned chatbots to human preference. Capable, talkative, surprisingly helpful, then occasionally wrong, biased, or strange. ChatGPT burst into public life like a stage door blown off its hinges. Students, coders, poets, scammers, everyone found a use. Awe wrestled with alarm. Governments hurried to set guardrails. Brussels wrote the AI Act. Washington drafted frameworks. Standards bodies hashed definitions. The question sharpened. Regulate potential or behavior? Innovation. Meanwhile, chips and power. GPU clusters sprawled like steel orchards. Gigawatts flowed. Cooling towers breathed. Rivers fed server farms. Intelligence at scale demanded a new. At Bletchley again, a new summit asked an old question. Can creators control creations? Safety researchers, CEOs, skeptics gathered where bombs once spun. History rhymed from bronze giants to silicon whispers. We keep asking, are we building a mirror or a rival or a partner? The answer lives in choices we make now. The oldest dream has woken.